Okay, so what does 2 look like? Going through just how we would say, so angle A is acute. A is not bigger than B, so that means we have to check H. And if we're checking H, I'm going to do it way on the side here. H is B sine of A. So H is 25 times, or 31, sorry, times the sine of 20.5 degrees. And H is 10.8. And if you're looking at look on your other sheet, your ambiguous case, we see that H is smaller than A and A is smaller than B. So this is going to make 2 triangles. And we want to find both of them. So we're going to draw the situation. We have to draw both triangles. Yes, you need to draw both triangles. And our first one, if we kind of look back at that ambiguous case, I've got a green and a red triangle. The red one's the first one that we're going to draw because that's the first one that shows up. And then the green one is actually our second triangle. So always that first triangle is going to be the one that looks like this. So we've got a 20.5 angle. We've got a 31 for our B. That's a long side, so I'm going to just show that. And then I'm going to have to extend this because our first one goes this way. So A is 12. We don't know angle B. We don't know angle C. And we don't know side length C. So the first triangle will look like this. It's that outer one. And really the difference between the 2 triangles, the difference in the 2, and again why we get 2, is in one of the cases B is the smaller angle and C is the biggest angle. And in the green case, B is the biggest angle and C is the smaller angle. So that's what's happening in these 2 cases. And the first one is always that B will be the smaller of the 2 angles. To show that we have enough information here, I've got B across from B, A across from A. I only have one unknown between those 4, so that's enough to start. If I'm looking for a side length, I like to use sine on top. So the sine of B is 231 as the sine of 20.5 is 212. We're going to multiply each side by 31. Sine of B then is equal to this decimal. I'm getting 0.905. And now I always leave a space here because I know I'm going to have to show it, take the inverse sign. Make sure you're showing this step in green here because I am not a mind reader. And that B angle is about 64.8 degrees. And we can put that in our picture. If I want to find angle C, I can add those up and subtract from 180. And then when I do so, I will get 94.7 degrees. And lastly, I need side length C. So to find side length C, I will say that C is to the sine of 94.7 degrees as 12 is to the sine of 20.5 using side length A and angle A. Multiply each side by the sine of 94.7. And C turns out to be 34.2. So using those initial conditions, B is 31, A is 12, and angle A is 20.5, this is one triangle that could be made. Now there's a second triangle that could be made, and that one always looks like this. So A was 20.5. That's given. 31 for B is given. Now this is going to drop on the inside. This is the second one that's always made. And we are going to use some information from our first triangle. And the information that we can always use is this. Put it in red. In triangle 2, angle B is the supplement to B in the other angle, in the other triangle. So this B right here is just going to be found by 180 minus that 64.8 that we had before, which is pretty nice. So when we do that, we get 115.2 degrees. And that's always going to be true. That will always be true. So to get the second one started, because if you started just doing law of sines, it's not going to work. You're going to keep getting the same answer that you did before. You need that information that we just provided, that those two are supplementary to get this one started. And now it's simple. Subtract from 180 to get C. 180 minus 115.2 and 20.5, and we get 44.3 degrees. And now to find side C. C is to the sine of 44.3 as 12 is to the sine of 20.5. And we'll multiply each side by the sine of 44.3 degrees. And the length for C that we end up getting is 23.9. So it's not that much more difficult or even work. We did one law of sines. We subtracted from 180 twice to get those. So it's not like it's an overabundance of work. But here are your two triangles that are made in the ambiguous case.